Okay, we're going to be solving what's called literal equations. They're just equations that can be used to solve for something else. So we will solve these equations just like we would normal equations, except we're going to have a variable still in our answer, which is okay. I also think of this as just simplifying. We're just moving stuff around a little bit. So number one says 4m minus 3n equals 8, and I want to solve for m. So I want to get m by itself. So normally, if this were just a minus 3, I would add 3 to both sides. So I'm going to do the same thing, except I'm going to add 3 into both sides. So I get 4m equals, I can't say that 8 plus 3n is 11n, because those aren't like terms, so I'm going to write them separate. I like to write the variable term first. You can write 8 plus 3n if you want. This is how I like it. Now I have 4 times m. The opposite of times is divide. So I'm dividing each term by 4 to get m equals 3. N divided by 4 is the same thing as 3/4 n. Then 8 divided by 4 is 2. I have m by itself, so I am done. So notice you still have the n in your equation, and that is okay. That's what we want. These types of equations are really helpful. And you will need to know how to do it for every math class you will take from here on out. It'll be very helpful when solving for other variables. Number 2, I want to get n by itself, so I'm going to subtract the 6p from both sides. My 15 and my 6p are not like terms, so I'm going to write them separately. I'm going to put the variable first, but you can put the 15 first if you want. Then I'm going to divide every term by 3 to get rid of the 3 in front of the n. Negative 6p divided by 3 is negative 2p. 15 divided by 3 is 5. We have n left on the right, and that's what I was solving for, so I'm done. Number 3, I forgot to say what we're solving for. We're solving for r. So most people, their first instinct would be the distributive property. So t times r is tr. T times 4 is 4t. Notice how I made my t. I don't want it to look like a plus sign, so I put a hook on the m. If you don't like doing it that way, then you can make it a capital T. I need to start getting r by itself, so I'm going to subtract 4t from both sides to get tr equals negative 4t plus 28. And then I still need to get rid of this t, so I'm going to divide every term by t. We get r equals negative 4t divided by t is negative 4. And then 28 divided by t is just 28 over t. Number 4, I want to solve for d. I notice that I have some like terms, so whenever I see I have like terms, I always start with those. So I'm going to combine my like terms by subtracting d from both sides. So I have 5c equals 2d minus 1. And then start getting d by itself, so I'm going to add 1 to get 5c plus 1 equals 2d. And then divide everything by 2. 5c over 2 is just 5 over 2c. And then 1 divided by 2 is 1 over 2. We have d by itself, which was what the goal was. 5 and 6 are very similar. If you look at the right side, it says 2 pi r, which means 2 times pi times r. So since it's all the same operation, I can move all of my variables at the same time. So since right now it's multiplication, the opposite would be division. So I need to move this 2 pi away from the r, so I'm going to divide by 2 pi on both sides. C divided by 2 pi is just c over 2 pi. And then these 2 pi's cancel, so it would be left with r. So that type of question is very helpful if you are given a problem and they want you to solve for the radius. So you can already get the radius by itself and solve it that way. Number 6 is very similar. We want w by itself. It's okay that there's an L and an H on both sides of it. It's all multiplication on the right, so I'm going to do the same thing as I did with number 5 and divide both sides by LH. Notice how I make my L. It's a cursive lowercase l, so it doesn't look like a 1. So either make it a lowercase cursive or make it a capital print L. So V divided by LH is just V over LH. And then those LH's will cancel to be left with W. Okay, so if you have any questions, feel free to email me.